So for the next few minutes we want to discuss some forces that are on a propeller, and in particular we want to look at what forces occur on the propeller when we have a windmilling propeller. So to begin, we will look at the normal forces on a propeller. So here we have an aircraft in normal flight. It has a particular velocity. It has a positive blade angle. And it has a positive angle of attack. And that leads to positive thrust and positive torque. And here we can see it represented in a 3D image, if you like. So here's our force, and here's our torque. Sorry, here's our thrust, here's our torque, and the propeller is rotating in this direction. Now, let's assume our aircraft experiences an engine loss, and to maintain airspeed the pilot will have to stick the nose of the aircraft down. So pilot has put the nose of the aircraft down to maintain airspeed. We have lost our engine, so the RPM will have reduced considerably. So the air is flowing through the propeller, and the air is now causing the propeller to rotate. So we still have our same airspeed, because we've put the nose of the aircraft down. We have a small RPM. That leads to a negative angle of attack. So we have a positive blade angle, so the blade angle is between the chord line and the plane of rotation. So we have a positive blade angle, but we now have a negative angle of attack. And the negative angle of attack will lead to negative thrust. We will also have negative torque. Now, when the wind is flowing through the propeller, it's causing it to rotate. Now we want to keep the propeller rotating in the same direction. So when the wind moves through the propeller, it's getting the propeller to rotate in this direction. And it can only do that by having a torque in this direction. So this torque is the wind causing the propeller to rotate the engine. In this instance, it's the engine rotating the propeller, and back here it's the propeller rotating the engine. So as the wind flows over the prop, it's going to cause this negative torque. So a windmilling propeller will have this negative thrust and negative torque. That negative thrust we call drag. And if the aircraft has lost the engine, it needs to glide, and you want to keep your drag forces to a minimum when you're gliding. So I've shown the propeller blade from both sides. So this side of the prop is if you're looking in from this side, and this side of the prop is if you're looking in from this side. So we have a positive blade angle, but we have a negative angle of attack. That gives us a negative thrust, which we call drag. So it would be a good idea to minimize that drag. And one way of doing it, or the accepted way of doing it I should say, is to feather the propeller. And when we feather the propeller, we increase the blade angle. So the blade angle goes from whatever it is here right up to about 90 degrees. Similarly here, whatever that angle is there, the propeller comes all the way down here and has a blade angle of about 90 degrees. And when this happens, the chord line is parallel to the relative airflow. So this is the airflow coming in, and there is no angle of attack. And if there's no angle of attack, there's no thrust, and if there's no thrust, there's no torque. If there's no torque, then the propeller can't rotate. So the propeller will remain stationary, and there will be no thrust, so there will be no drag due to this windmilling propeller. So that is what the feathered propeller would look like. Okay, so it's perfectly stationary, it's not rotating, and it's not creating drag due to the windmilling action. The other benefit to it is the propeller has some profile drag. So in this instance, this is the frontal area, which is reasonably large, but when we feather the propeller, the frontal area is reduced. So we reduce the profile drag. So by feathering the propeller, we reduce the drag due to the windmilling propeller, and we've reduced the profile drag as well. So all of this is good. And the following is a picture I have of a feathered propeller. I borrowed this from YouTube, and you can see the propeller is in stationary position, and the blade is at an angle of about 90 degrees, so it's not rotating. Right, sometimes though we might desire to have negative thrust, and such an occurrence might happen when we're landing. So when the aircraft comes into land, it will have some airspeed, it will have a positive angle of attack, there will be some amount of thrust, it's going down the runway, and as it's going down, the pilot is pressing on the brakes, so reducing velocity, and he may want to put on a power on brake, and to do that he will change the blade angle of the propeller. So now we get a negative blade angle. Okay, so with a negative blade angle, so the blade angle, if you recall, is from the chord line to the plane of rotation. So we have a negative blade angle, and we will also have a negative angle of attack, and that negative angle of attack will give us negative thrust, which we call drag, and that's going to slow the aircraft down, and that's what we want because this is a power on brake. So with the power on brake condition, we have a negative blade angle, we have a negative angle of attack, we have negative thrust, but our torque is still positive because the propeller is being turned by the engine. Okay, the engine is still turning propeller, so we have a positive torque, and the propeller is trying to resist that. So this is this positive torque. So I hope that helps summarize what happens with a windmilling propeller.